Hi, welcome to the YouTube Mall Builders Wednesday night Arduino workshop. Quit reading the monitor. Uh, anyway, want to say hi to everybody and let you know, go to YouTubeMallBuilders.com. There you can check the schedules for our shows, the Tuesday, Wednesday, and the Saturday show. Tuesday and Wednesday shows are at 8 o'clock Central, 9 o'clock Eastern Time. The Saturday once a month live show and the Thursday weekly show is at 9 o'clock Central, 10 o'clock Eastern Time. And don't forget to click on the e-mag and be sure to sign up for email notification there. JD and his team do a great job putting out a free magazine full of content by the people of the community, for the people of the community. And let's see, I guess y'all noticed in the title, Chris Heili had another appointment tonight, obligation, couldn't make the show, so he has brought his double in. I don't know how good of a stunt double he is, but anyway, his double will be doing the show tonight. That'll be Chris Rude. He's going to do a fritzing show tonight, show you guys how to use the fritzing program to draw out your breadboards and all before you wire them up to help make it easier. So with that said, I am going to switch over here and turn the show over to Mr. Chris. Hi, Chris. Show's yours.
Good evening, everybody. Like Johnny said, tonight we're going to talk about fritzing. And what fritzing is a program that allows you to take your breadboard design and your Arduino board and create a view so that you know where every piece of every wire goes, every component goes, and how it connects. Okay. Fritzing also allows you to create schematics, PCB, and do PCB layouts so that eventually you could take your prototype, which you did on your breadboard, and have it actually physically manufactured so when you go put on the layout. But what's great about it is as you're building your circuit, you're prototyping. So this allows you to trace your steps from beginning to end. So your end being your end product. So Chris has been talking with a lot of you folks. I've been on the panel. We've been talking about servos. We've been talking about stepper motors, all kinds of stuff that we can implement into our model railroads. So one thing that, and I'm sure Andy will agree with me on this when I say it, is we have a tendency to just to kind of put stuff together, put it on a layout and forget about it, where we really need to be bookkeeping and tracing our history back so that when something, God forbid, breaks or we need to rebuild it again, such as, like, say, if we're using servos and Arduino to control our turnouts, you know, we build the circuit one time and we're going to implement that 10 times through our layout. Well, we can remember where we did it 6 months ago, and now we're doing a new module or a new section of the layout where we need to implement that. So you could kind of remember, you know, it's more or less of tracing the hardware than versus tracing your software. You know, we talk about when you do your software side of it, not to get too deep into that putting comments in so that you know where you've been. Well, fritzing allows you to take the physical board component and keep a history on it so that you could utilize it. So basically what we're going to do tonight, we're gonna kind of walk you through on how to do it, show you the program, that kind of thing. Here's a sketch that I built when we did the stepper motor. Maybe some of you remember I showed this on the one live show with Chris. So this is what I did when I built my prototype of my stepper motor, because I'm going to use the stepper motor to animate some of the stuff on my layout when I build it. So I built this so I could kind of remember how, and there's a lot going on here. This is kind of complicated a little bit for the beginner, but I just kind of wanted to, it was a better circuit that I had laid out to show to start with. So this is what we're gonna do. We're gonna do two different kind of sketches tonight. We're gonna do one with an LED, and we're gonna do one with a servo and a push button. to eliminate a turnout. So why don't we we'll dive into it. The first one we're going to do is we're going to do our LEDs, yeah. So basically, this is I forget if I'm sharing my screen or not. Okay, am I now or no? No. Sorry, technical glitches all the time. So this is fritzing. Okay, so right now I'm in what they call the breadboard view. So this is our breadboard. So why don't we talk about what the breadboard is? The breadboard is basically a board that has all these little connection holes in them. Okay, so you see this blue line. This is your what they call your negative rail, and if I click on these are all connected. Ooh, didn't want to do that. These are all connected electrically. Okay, this here is our positive, what we call our positive rail. These are connected horizontally, as you see the yellow dots, right across. And there's the same positive rail and negative rail at the bottom of the board here. So these columns, as they call them, so you have this column, these are connected electrically this way, and there's a divider here. And I'll explain what the divider is in a minute. And then these ones on the bottom side of the divider are connected electrically. And then this divider here is actually used for when you want to use integrated circuits or IC chips. So that allows you to put the IC chip right here in the middle and use these holes here, and these holes here is for the IC. Okay, so now that we have a kind of a little basic understanding of the breadboard, let's get rid of this real quick. Yeah. So, and then on the right-hand side of the screen, we're going to see all these parts. And you're going to see, if you downloaded fritzing, I made a post on over the weekend, if you're going to follow along to download it so you can follow along with us. I'm going to have a little bit more parts than usual because you could download extra parts, like, you know, Adafruit has their parts that you could download for fritzing. So when you're using their components, you can drop them into your diagram. So here, you know, we have our core components of, you know, resistors and capacitors and push buttons and petanometers, pots, LEDs, some basic ICs. There's all kinds of stuff in here.
Hey, Chris,
yeah.
Quick question while we're covering that on the breadboard. The upper set of rails, the bottom set of rails, and the way you got this board on screen, those aren't connected. There was some questions in the chat about those being connected. They're not connected on any breadboard I've ever seen. Also, a good positive is I often use wood for 3.3 volts. Arduino has 3.3 and 5. Mm-hmm. So I often use one set for 3 and one set for 5. But
yeah. Yes. These are not, so these are separate right now, as you said. But let me get a new sketch because I'm getting dots here.
But a lot of times you're going to use both sides to make your wiring leader. You might want to wire them together.
The only way these become connected is if I make a connection here. So if I put this wire here like this, I connected this positive rail to this positive rail. So when I hover over or hit the dots, now they're electrically connected. But now if I remove this, when I highlight it, that rail is only connected. The bottom positive rail is not connected.
And fritzing has that convenient thing where it lights up the breadboard. The same thing will happen in other circuits as they get kind of complicated, where it can light that pathway. Makes it easier to kind of mentally keep track of where the electricity, or if you think about it, the water analog, a lot of people do for electricity, how that flow is connected.
Yes. I posted the link on the Google Plus page, but I can give it to Andy really quick here.
I'll paste a link in the chat for everybody to get it. Of course, Googling fritzing, just Google fritzing.
Yep.
But I'll drop a link in the chat in just a minute. You have to modify the link because I can't put a good link in the chat. But
that brings up a good point too that I forgot to mention as we started the show. This is open source. The Arduino stuff, as far as software is concerned, this is free to use. There'll never be a charge for it. So anybody can go out and download it and get it. And as soon as you download it, you have the full-fledged version of it. So you don't have to worry about, you know, downloading it and getting a light version and then having to pay to get a full-blown version.
It'll say something about when you go to download it, it'll ask you about a donation of 10 or 25 pounds or whatever. If you say no donation, you get a free download. So
yeah, they're just looking for donations to keep the project going and moving along.
Sure. If you use it, I'm going to do everything I build. I'm going to do a fritzing diagram for, because this Arduino stuff's rock solid. If you build it and in 5 years, it's worked great. You know, Arduino will do that, just set and run for years without ever being touched, unlike a typical computer requires cleaning them up, antivirus, etc. These things will just set and truck. So you'll forget how easy it is to forget this stuff.
Right. Right. So there's, and this could be used not just for Arduino, but for any basic electronics, for any, we don't talk about it that much on here, but the Raspberry Pi, which is the single board computer, you can use it for, because they have the GPIO pins, general input output pins, that, like the Arduino, can sense the physical environment or can control the physical environment, except it's a full-fledged computer. So you can also use this for that too. So kind of going back, just to kind of give you an overview, and we're not going to go through all of these, but you know, this is our basic parts, which we're going to use tonight, and then we're also going to use our Arduino. So as you see, I'm loading up all the different Arduino boards that are on the market. So if I want, say, we're going to use the Uno tonight for our example. So I click on the Uno here, which might be hard to see, but if I pull that out, I drag it on the screen. Okay, now I have my Uno board. Okay, so we're going to pretty much use the digital side of the board. So we're going to rotate this to make it a little better for our viewing pleasure. And you know, if you hover, this board is kind of smart. It's not really an image. It's a smart image, I guess I'm going to say, for the lack of a better term. So if I hover over a pin on the Arduino board, it will tell me that, you know, this is digital pin 1, and it's actually the transmit pin for the serial line. If I hover over this one, it says it's digital pin 7, which it tells you on the board, but it's kind of convenient sometimes when you're dealing with, you know, breakout boards, which are boards that, you know, are basically a circuit that you can use to connect to your Arduino, and you need to know what is what. We'll kind of show you that when we get into the other parts here. So what we're going to do first is we're going to take a sketch, and we're going to use 3 LEDs, and the 3 LEDs we're going to assume are going to eventually blink in a pattern. So let's assume for this example that on our fictitious layouts we have an airport, and we want to build the runway lights that flash up and down the runway. Okay, so I have my Arduino board here. We're going to prototype this. So now if I go down to here and I go to my core components, where are my basic components, and I hit LED, okay, I'm going to drag the LED out, and we're going to need 3 of these. Okay. And let's say we're going to have a red. And since it was just the 4th of July, why don't we say we have red, white, and blue. Be a little patriotic about it. Okay. So on an LED, just to kind of refresh a little bit, I don't want to dive into the electronics part about it, but since we're building an electronics diagram, okay, if I hover over to these leads, this is the cathode side, so that's the positive side of the LED, and then I have the anode side, which is the negative side of the LED. So this part of the LED in the diagram that is bent is telling you that that's the negative rail, or the negative side of the LED. Okay, so now what we're going to do is we're going to bring these down, and we're going to connect them here. And I'm going to flip this. No, rotate it. There we go. Let's rotate it like this. Okay, so we'll put this guy here. Okay, so we're connecting. This is going to be our positive again. This is going to be our negative on all 3 LEDs. Okay, so the first thing that I want to do now when I'm laying this out is I'm gonna use 5 volts. So I'm gonna go over to my Arduino board, and it's upside down. So my digital pins are here. Just really quick to refresh the people at home. And up here is where my power is. So I want to pull 5 volts out. So here, see, now this is how we make our connection with our wires. So I just put a wire on this positive rail that we talked about a little while ago. Okay, with fritzing, see how that wire is kind of on an angle and it's not clean? Well, I can click it and I can bend it. Okay, so I'm bending it up to make a little, because we don't want these diagrams to be all messy. We want them to be clean, because especially if we're using it for future reference. You know, even for prototyping, you don't want it to be a rat's nest of wires. You know, we want to be able to know what we did and why we did it, and keep track of it. So what I did there, I'm sorry I didn't explain what I was doing, but I changed the color of the wire to red, because I like to use red for my positive and I like to use black for my negative. So I just right-clicked on the wire color, and I selected red. So now we need to connect our ground. So what we're going to do is we're going to drag this one out. We're going to go to, right-click on the wire. We're going to wire color. We're going to go black. So we change the wire color. We're going to drag this one up, make it look nice. Okay. So now I have my 5 volts coming off of my Arduino board to the breadboard, and I have my ground coming off the Arduino board, which is our negative to the breadboard from the Arduino. So now what we're going to do, and really we don't need that positive or negative rail for this example, because I'll show you in a minute, but I just kind of wanted to show you the basics of wiring something quick. That so with the LEDs now, we have these negative. We got to connect our negative to the negative side, because our positive side is going to go to the Arduino. So what I'm going to do now is, since I have my positive and negative brought over, I'm going to take my negative on my LEDs, which is right here, and I'm going to bring them up over to here, which is our ground, which is also called our negative rail. So we'll do that for all 3 LEDs. Okay. So now we have that set. So now what we're going to do is we actually have to add resistors for the LEDs to connect them to the digital pins on the Arduino, which is our pull-up. So when the current flows to the resistor, it gives the LED enough current to light. So the resistance value of the resistor, depending on what I use, will either brighten the LED or dim the LED. So we're just going to pick an arbitrary value for the resistor at this point, just because we're demoing drawing the diagram. So here's our resistor. So again, all we have to do is drag it out. Okay. So I dragged it out. This is a generic LED. So say I'm doing a diagram and I need a 10K resistor. So in my right panel here in my inspector view that I'm circling around with my mouse, you go down to resistance and it'll show, you know, all the different resistance values of a resistor. So 10K resistor, and so on and so forth. So I'm going to use for this example, I'm going to use a 220K ohm resistor. So what we're going to do here, we're going to bring this over, and I'm going to copy it. I'm going to paste it. I'm going to paste it again, because we need 3 of them, right? Because we got 3 LEDs. Probably should have rotated it first before I copied it, but oh. Right. So I'm just using this button down here to rotate the objects. You can rotate them. If you click it a little more, it'll rotate it 45 counterclockwise, so on and so forth. I typically just hit the rotate button until I get it where I want it. So here I'm going to drop the, so again, before I put the resistor here, we're going to put now remember with a resistor, it doesn't matter which way, it's not like a capacitor. It doesn't matter which way we connect it. So you could connect any side of the resistor to the LED, and it doesn't matter. But if it was a capacitor, it would. So now I'm going to bring this over, and I'm going to snap it to this hole right here. Okay. So now, if you watch, I highlight this here. It's hard to tell on my mouse. Let's zoom in a little bit here. You see the yellow dot showing up because I'm clicking on it. That means that resistor is connected to the LED. So now what we're going to do is we're going to connect the red LED to digital pin 2 on our Arduino board, our Arduino board. So now what I'm going to do is I'm going to bring because remember, these are connected electrically now from this column to this column. So what we're going to do now is we're going to bring this over. And say we make this a gray wire, just because we already used red for our positive. So now I'm going to bend it around. So now if I click on the pin, the LED is connected through the resistor to the Arduino board. So now we'll connect our white one. So we'll bring up our wire again to pin 3. We'll use pins 2, 3, and 4. Okay, let's change the wire color. Our wire color is going to be all off because I can't really use white because it's not going to show on the screen. So we'll make that one yellow. So, oh, I made a boo-boo. I didn't connect my resistor in there. See that? So we got to put our resistor back in here like we did for the red one. And I just moved it. So you see how it could snap? I can just slide it up if I make a mistake. You don't gotta. It's not a big deal to make slight modifications like that in this program. So now, we got our red or white connected. So our red's connected again to pins 2. Our white's connected to pin 3. So now we're going to connect our blue one to pin 4. So now we're going to bring this resistor over, connect it in, and run our wire to pin 4. And I can actually make that one blue to match the LED. So basically, we're done. This is our sketch. So besides the code side of it, we have our hardware side of it set. So we write our code to make these LEDs alternately flash. So and we can add more here if we want. We can add 3 more. I mean, we have the pins to do it. But again, the key here is that, you know, we're using this to kind of lay out what we want before we actually do it on the layout. Fictitious runway lighting system, you know, and you want to draw it out from your head or from what you're researching online. You can certainly do that here, and then, you know, prototype it on the breadboard and test it out and see if it works. Oh. Is it back on now, Johnny?
I see it.
So, technical difficulties here. So, you could do this one or two. Like I said, what I was saying was, we can lay this out before we actually build the circuit, or while we're testing it and building the circuit, we can lay out this out while we're doing that too. So, you know, you want to see from something, an idea in your head, just lay it out here and then try it on the board. Or you're trying it on the board, try it on the board, and
You do, yeah.
yeah, you could do that. So what I would do is I would just copy this. So I'm going to copy this red LED, and I'm going to paste it. Yeah. Paste.
Hang on, I just lost Toby.
It just went offline.
All right, Ralph, get off of here. No.
I think you got a stream coming back.
Let me go check my internet real quick. All right, I've got internet.
I think you're back.
All right, sorry about that, folks, but we had a internet interruption here, so we're back online again and broadcasting. I think we went offline as I was asking Chris if about connecting, having two blue LEDs, how you could connect those two together, have two of them and both of them flash at the same time. Or is that possible?
Yeah, it is. So what I would do is copy the blue LED that we already have on the breadboard, and then I want to let me paste it. I had to use Control V to paste it. So bring this over. Okay. I would put it there. And now I'm going to I need another resistor now, right? Because I need a, just like the other ones. So we put another resistor on the positive side. Actually, I'm going to move this down a little bit to give myself a little room here on my diagram. So now what we need to do is we need to bring make our ground connection to the LED. Okay. What I would just do, if I'm going to prototype this, because you want these to flash at the same time and you want to do it via hardware, not software, I would just bring this wire, bring another wire over to here. We'll make that one blue too. So now everything is connected. So when pin 4 goes high, it'll light both these LEDs up at the same time. Now, is that the way I would do it? No. I would do it in software. So I would basically do it so that I would just use another pin on the Arduino board, and I would tell my software to light both those pins up at the same time.
It depends. It depends on you know, how you're using your board, how important outputs are to you. So
Yes.
you have an Arduino Nano, and it's you're so cheap that you can put whatever structure of your layout. That's what I've decided to do.
Yeah.
You've got a bunch of pins on there. If you're only putting 4 lights in a building or whatever, then it's trivial to overuse to not be efficient with your pin utilization.
Yeah, if you're not tight on pins, yeah, that's the way I would do it. But you're right. The one thing we got to remember too, though, is you know, these pins only put out so much current, so you don't want to overload the pin either. So you know, that's just something that you have to work out in your design of what you're doing.
And adjust resistors. So if you have 2 LEDs on one pin but only one on another, and you want them to be the same brightness, you may have to adjust resistance a touch. I had my single heads.
Yep. So when we were offline, Lloyd asked me about the LED colors because he kind of missed that step. So what I'm going to do is I'm just going to kind of go over that really quick again. So we're going to go back to our parts panel here. We're going to go to our output. We're going to get our LED out. Okay. So again, like I changed the resistance of my resistors. That's a tongue twister right there. I could go back to my inspector panel where my LED is. Okay. And see it says color. I could drop that down. Okay. and you could change that to red, orange, whatever. Okay, so that's how you change the color of the LEDs, Lloyd.
Oh, okay.
And I found something interesting that you might be interested in. There's infrared LEDs in here. So we might have to look at that for what you were talking about before.
Yeah,
Oh,
I found the dedicated board for the emitter and the receiver, but not the combination board that has the emitter receiver pair on a reflector set. That's the only part. There's also a big base of other circuits available on the internet. So if you find a board in this unique case, Lloyd has a particular board we've had trouble finding the particular fritzing component for, but there's a lot of fritzing components out there that are freely available that you can add to fritzing.
Yes.
And it also prints, by the way. So if you've built a layout or a house on a diorama and it has a complicated, or a structure on a diorama and it has a complicated lighting arrangement, or if you wanted to make paper hard copies of these documents, fritzing will print these documents for you so you can keep them long-term archival storage.
Yep. And so before we dive into the next part, I think this would be a kind of good point to explore the other parts of the program a little bit, just to kind of show you people the schematic and the PCB part of it. So now when we talk about these different views, and I don't know if I'm using the word view the right way, but we're going to call them views for this discussion. You had like I said, you have the breadboard, the schematic, and the PCB. So whatever you do in the breadboard shows up in the schematic, and whatever you do in the breadboard and the schematic shows up in the PCB. So a schematic is exactly what it is. It's a schematic of the electronics diagram. So it's going to be bare bones what electronics engineers use to build their circuits, especially for PCB design. So if I go to my schematic, you can see it brought everything over that we have in our breadboard view, but it's messy. It's not pretty. It's messy, but we could kind of clean this up a little bit to kind of get it so that, you know, it's not as messy, and
it'll keep all the links and try to reroute the wire for you. Also, when you're designing schematics, at the bottom in the red, there's a status bar. So if you ever start working on wiring a servo in or a set of LEDs and you don't complete that part of that loop so that you have a control or a pin going out to trigger a pull up to ground or out through the positive back to ground, it will show you at the bottom that you don't have, if it says 0 of 8 nets routed, it's just had 12 connections to be routed. So you can actually use that to have it help you diagnose your wiring routing.
So, and to clean this up is it's not really a big deal. We just got to find out, you know, what is what here. So, this must be my other blue LED. This is my blue LED.
The fourth board you added?
Yeah. So this has to come down here someplace. So let's rotate that. Oh.
And it will do some intelligence for you. It'll try to route the wires to the most convenient way, but
so this is messy. This is let me get rid of that other LED that Johnny had me put in, because that's kind of throwing everything off here. So let's just do this really quick.
yeah, I would have blamed it on Johnny too. I'll back that decision.
Yeah, sure. At least he laughs about it. I mean,
Absolutely. I wouldn't have said it if I didn't know Johnny could.
take the joke, right?
Yes, sir.
So flip this around. And again, I'm just using the same rotate command like I used before. Okay, so I'm moving this the resistor over, bring the blue LED up.
And you could try auto routing at the bottom as well. Although
Yeah.
I don't generally have the best luck with auto routing.
I don't either, and I tend to always kind of do it manually.
I do too.
So,
but auto routing may work if you have a quite simple circuit that has a lot of repeated stuff, like wiring a house, you know, controlling the lights for a house, or a crossing gate flasher. That's really a simple circuit. Auto route may very well work perfectly for you.
yes. So
That makes sense.
just kind of scoot this down a little bit here, so the people at home know.
Well, that makes pretty good sense.
And sometimes it gets used to, you got to get used to using this, because you see like how I'm clicking on stuff and it's highlighting stuff, and I really don't want it to do that. So sometimes you know, you got to kind of play with this a little bit to get it to work. I got to rotate that one. I didn't rotate that one. Okay. Delete that one. So as you can see here, we kind of organize this a little bit just by kind of clicking on stuff and moving it around. That image, for some reason that text box is not in the right direction. But see how these have these little dots, or these little dashed lines, which are typically called hidden lines. That just shows that they're traces. So if I want to make them a permanent connection, what I do is I just click on them. So that makes them all permanent connections now. And how I want them to be laid out. So now I have this everything, all these LEDs connected to ground. So now if I connect them to ground like this by double clicking them, now I can kind of modify this connection here and make it a little bit more prettier. And now I have my schematic laid out for our 3 LEDs. The problem between the schematic and when you do stuff in the breadboard and you initially lay it out, you have it all nice and neat. But when you go to schematic and you go to the PCB view, everything's going to be scattered because the program doesn't know how you want it organized or how you want it laid out. And the problem, and that what kind of the downfall of the program is, it gets messy. But any electronics program that does schematics or PCB views will tend to do that. Sometimes some aren't as bad, but you know, now I have my schematic, and the schematic you kind of need for, and the PC is really for your PCB view. You really don't need it if you're, I mean, if you're going to trace of what the project you've done on your layout. But if you're going to make a PCB for your Arduino board, like a shield or a breakout board, and a shield to really to talk, kind of just define those terms. A shield is a board that really sits on top of the Arduino board. So it has pins on it, and it'll go into the pins of the board. And when I say breakout board, I mean a little circuit board. It's a little PCB that doesn't sit on top of the Arduino, but you have to wire it in separately. So when you're doing your product, and let's assume that we're going to make a PCB out of this, so we lay out our schematic. The PCB manufacturer needs to see your schematic. Sometimes if there's problems or something like that, they'll reference your schematic. But for the everyday, you know, Joe Schmo that's going to be doing model railroading, like myself, or in that, you pretty much just need the breadboard view, unless you know how to read, you know, electronic symbols. Like you see how the LED shows up, like the triangle with the line and the 2 arrows, meaning that's an LED. And then the wavy lines, which means it's a resistor. I mean, unless you're into all that, you're typically not going to use it, again, unless you're making PCBs. So I'm going to show you the PCB view now. since I just showed you the schematic, and I'll show you how we just organize schematic and our breadboard. And again, our breadboard is all nice and clean. Our schematic's kind of nice and clean now. So now when we go to our PCB view, everything is all over the board. So this here that's highlighted in the darker gray is literally our Arduino. And this here that I'm highlighting, which is probably tough to see, is the actual PCB that this diagram's for. So if I right click on it, see how it's bigger than the Arduino? Well, I need to tell the program that, well, we're going to build an Arduino shield. So if I go back to my inspector again, okay, and it has shape here, if I drop that down, it's going to say Arduino shield. So we get the Arduino shield. And every time I do that, though, it doesn't line it up with the actual Uno. And I don't know if that's a fault in the program or if I'm doing something wrong. But what I typically do is I find where my Arduino board is, and I see this says location 0.597 and 0.100. That's the location in the XY direction of where the physical board is. So if I go back to my shield, or PCB, as the program's calling it, 0.597. I think it was 597. Now our PCB is overlaid exactly on top of our Arduino board. Okay. So now we have all these parts, and I'm not going to dive into creating a nice PCB right now because this is really you really got to play with the program, and kind of PCB design is kind of its own animal. You kind of have to spend some time learning it. I kind of learned it. I want to make some of my own PCBs. Andy and I were discussing that earlier today. But you have to worry about how you run your traces, which are your physical lines here. That these dash lines are what they call traces within the PCB. They could be layered.
It adds cost.
Yeah, and
they want it to be straight.
Right. And there's a top couple, and yeah, you want them to be straight. There's lots of things involved with it, and I'm not going to dive too deep into that. But there is several places for the hobbyist, typically the electronics hobbyist, where you could get your PCBs made up. One is the organization or the group of people that create fritzing have what they call fritzing labs. So if you go to fritzing.org, you'll see that it's fairly cheap, and they'll take your sketch, your diagram here that you create in the fritzing program, and physically make you a PCB. And I believe that's done in Europe. I think it's in Germany. And then there's another company called Oshpark, and Oshpark is widely used by the electronics hobbyist community. The only downfall is you can't just order one board. I think you have to order a minimum of 5 boards, and I apologize for not researching that prior to the show. I remembered that. I know there's a minimum number of boards, so that's not a bad thing, because you might design a cool circuit for your model railroad, and your buddy comes over and he's like, "Oh, how'd you do that?" You can kind of give him the board and say, "Here, have at it."
Well,
so,
I mean, you can buy 5 for a whole lot less than you could buy a product. Right.
So, I mean, so it's not really that big of a deal. So, is there any questions in the chat or anything before I?
So Martin gave you a hard time. He showed up. He said it's time for bed. So he's kind of got you down there, though.
Yeah, it is time for bed, Martin. You're right.
If anybody's got questions, you can paste them to the chat. I think there's a place for PCB. Having boards printed. I mean, etching your own board. We were talking about doing that. It's a great fun if you're the kind of geek that maybe me and Chris and some of us are. Etching your own boards is not necessarily for the faint of heart. However, it's not incredibly hard, but it's just not something most people are not going to enjoy. But if you could design a quick circuit And especially using code that's freely. I've said this every time we've talked about Arduino for the very first show. There's so much out there in the community around model railroading in support of Arduino that you could reuse so much that you could steal it and use that bit of code and build a crossing flasher with next to no work and with very little programming knowledge or experience. And you could draw that out for your own records. And if you decide you want to take that, instead of soldering it together yourself, send it off and get a board printed, it's a few bucks.
Yeah, I plan on making them pretty much. Well, I'm a tech guru, probably in the hobby. That's where I am. And you know, when I do the ideas that I have for when I build my layout, you know, I'm gonna probably make a lot of PCBs or stuff just because I want to keep it clean and neat, and I don't want to have 20,000, you know, nest of wires underneath my layout. So the PCB would kind of help me there. I'm not saying I'm gonna do it for everything, but to a certain point, I think, you know, and there's boards out there. You might not have to do all this. You know, there's people out there that have this as a hobby where you don't have to spend your model railroading hobby being an electronic hobbyist. And if you like it, like me and Andy and some of the other people within the YouTube model builders community, have at it. Come in and dive in with us. I mean,
a lot of us make PhD on boards. That's going to be I'm sure that's going to be a common occurrence. Many of us are trying to solve the same problems, and they're either not available or expensive or proprietary. So a lot of us will end up designing our own boards, and if we go together above, we're getting taken over by Australians, by the way, because Andrew Gilmore's had quite a bit of comments about this. He's a prolific electronics guy in our community as well. He says they'll also normally put multiple boards together to make a single board that you could stamp out or chop out. So a lot of times you could get a lot of bang for your buck, and a lot of the circuits that we need in our hobby are just really simple. They need to do something. They have a transistor for a flip-flop for crossing gates or whatever. They're incredibly simple boards. So you could buy a board that has 6 or 8 on it, and it'd be out a few bucks.
I'll be honest here while we're talking about it, because I want to tell people how easy getting into this stuff is. You know, before I got into Arduino and some of the other stuff I'm into, I didn't really understand the electronic side of it. You know, I come from more of a programming background than anything. With that being said, by learning Arduino, I learned the electronics. So you get more than just learning Arduino. You get to learn more of some of the electrical side. You get to learn how to maybe do some programming. And it's really, everybody's like, well, I'll never do that. I'll never do that. But it's really not that hard. If you have the time, there's tons of resources out there. And I don't want to dive too deep into this, but you know, you go on YouTube and research it. Type in Arduino, and there's tons and tons of videos. It's open source community. So what we're doing here in YouTube Model Build is open source. You know, we're sharing ideas and everything else related to model railroading. There's people who do electronics, hobbyist electronics, and they share tons of stuff on YouTube that we could pull and implement into model railroading. Like, and if you want to write your own sketch, which is what a program in Arduino is called, have at it. Learn it. Start small. Think big. The Toma concept, I hate to say that, but it's the same thing. It's the same thing with this stuff. Small and big. You start out small, and Lloyd, Andy and I were helping Lloyd out with his speedometer that he's building, or trying to build for one of Chris's shows. And I tell him all the time, I was telling him, and I think Andy told him the same thing, take it piece by piece. So add the LCD screen in, get that going. Add your sensors in, get that going. As you do that, you're modularly building the circuit, so that you know
how the internals of a little bit of code works. You need to understand that when this bit of code is present, the LCD comes on. That's how far you need to go down the rabbit holes. You can go further. You get totally obsessive, like me and Chris tend to, over the right way programmers do this stuff. You don't have to do that to have a model railroad with activity and with life to it, without having to spend thousands of dollars on circuits that cost 12 cents to manufacture.
I truly believe this stuff right here is the future of model railroading.
No question.
When you could build a DCC system with one of these and not have to spend $100, $300 for a command control system for your layout, life's getting good. That means there's more money in the bank to buy a scale big boy, or that that big diesel that turbine diesel that you want, or the 21-inch passenger cars that you want to put on the layout, whatever. There's more money for that, and you're not dumping all your money into the electronic side of things.
And the
because these things
not that removed. Sorry, Chris.
No, that's okay.
If you went out and bought this, if you went and bought, this is an argument we've had numerous times on Arduino in general, and less to do with fritzing than anything else. If you went and bought, I have nothing against. I think Digitrack's one of the greatest systems out there for a buy. Just put it, they have a complete solution to everything. Signaling, turnouts, you name it. I also like NCE. Probably NCE is my preference actually, but they have solutions to all this. You think you won't have to figure some of that out too? You still have to figure out how those boards work. It's no different. There's the barrier to entry for putting a Digitrack system in or doing it with Arduino is about that.
Yeah, and the thing with that is I tell everybody I do 3-rail O scale. Our systems are pretty much proprietary. So I have like tons of money tied into command systems between 2 different manufacturers. When I started getting the narrow gauge 130 stuff for to roll my 3-rail stuff, I didn't want to spend another $200, $300 to run my 130 stuff. So that's where the DCC++ comes in nice. I'm already implementing JMRI into my future layout, so why not use it? It's going to give me this.
And it's not compatible. If you go buy components for JMRI is a great thing. I'm an absolute advocate of it because it can allow you to have an NCE command station for locomotion to control your locomotives and for programming, and a Digitrack system for signaling, and a LCC system or CMRI or whatever. There's a whole host of these things. You can have all those systems together. JMRI can bring that together as well. So Arduino fits into that same mix the exact same way, or any custom electronics. Fritzing isn't dedicated to Arduino at all. It doesn't matter what you're building. If you're drawing a control panel out and you've got to wire that with a complicated diagram, you would do yourself a lot of justice to draw that out electronically and print it and spray glue it to the inside of the control panel or something. You will forget this in 5 or 10 years. I don't care how many hours it took you to initially build it. 10 years from now, when you haven't had to touch it, you'll have forgotten. Burnett 42. Yeah, we've had him on a few times. He said a couple things. I'm glad you're back. I seen you comment that a few minutes ago as well. He says he loves the passion and enthusiasm. It's encouraging to us beginners. And I would say me and Chris are not that far removed from beginners. The thing that I think is so fascinating about the Arduino show that Chris Heili has kind of wrangled us all into is that we're all at some level of the beginner stage. I mean, I have a degree in electrical engineering, so I have some historic background, but I went to school a lot of gray hairs ago. So it's been a minute. He's reignited my enthusiasm about it. Because what we're doing on when we get together, we often go to these rabbit holes on normal everyday shows. Come into a normal show and hang out with us and chat. We'll hop over into an Arduino room and go down that rabbit hole at any time. Me and Chris are bad for that.
Yeah,
but
yeah,
it's a big community of support.
We may be Andy and I may be beginners. We may be in the intermediate, in between the beginner and intermediate. But I've only been playing with this stuff for a year. And how I got into it, and I don't, I wanted to do my own animations on my layout when I build my layout. And I was looking for a way to do it because I'm not an electronic engineer. I'm a structural engineer, but I'm not an electronics engineer. So I was looking for ways to easily implement it into my railroad. And I also was in, getting into, I have a programming background from when I was in high school and when I went to college, from my degree. So this was maybe on the programming side easier to pick up on, but the hardware side of it is where I lacked a lot of knowledge. And now I find myself understanding, oh, well, this is why you need a pull up or a pull down resistor, or this is why you need a capacitor. Not saying I know it all. I don't. You're never going to know it all with anything. But I can actually speak the language and kind of have a clue to what's going on.
And
if
it
you
doesn't take
don't,
that long too. Most people
no.
think that they're going to spend years away from model railroading to pick up a new hobby at this. I disagree with that completely. I think you can
And if
build a
it's
crossing flasher in a few hours worth of research, even if you're not an electrical guy. The instructions and the fritzing diagrams and the source code, the sketches that are already out there. You can go pull the fritzing diagram off the internet of the picture, pull a couple wires together to a breadboard, and light some LEDs and get a lot of self-gratification from doing that in an evening, easily.
Arduino.cc, which is the official website. Arduino has tons of examples. Adafruit has tons of examples. And you'll notice
Model Railroad
that,
Hobby.
yeah, not a hobbyist, but you'll notice that all the diagrams that they're showing on these web pages on how to build these circuits and implement the code are actually fritzing diagrams. So what we're going over today is actually what they're using to teach people how to learn this stuff. So, I mean,
EagleCAD is a piece of software I've used in the past. It's intense. It's if you have ever seen AutoCAD or thought about designing your railroad or something, I'm not saying it's in the same ballpark as that to do it. Fritzing is kind of in the same vein as paint or something. So I mean, you're dragging a couple components together, pull its wires with it. You don't have to be an artist. You don't have to be an electrical engineer to understand this. If you know that you need 2 resistors, a couple LEDs, you can pop it together.
all right, let's hit the home run. Let's say you're a scratch builder. You're like Lloyd. Let's say you're Lloyd, fictitious Lloyd, not real Lloyd. Okay, so you like to do a lot of scratch buildings. Okay, but you wanna bring your buildings into life on your railroad. So you want to light them. You want to add some animations into them. Guess what? This is the perfect thing to do all that.
Maybe the only way to do it without building your own circuit boards, like Andrew mentioned, he's built his own computer, which I'm enamored by. But I've assembled a lot of computers in my life. That's what I do for a living as well. But building a main board, the way those guys built the original Apple Ones and some of those British boards, like some of that Andrew's doing some of that stuff. There's a lot of people in our hobby that cross over into electronics. That's why I think there's so much support for it. And Martin mentioned Jeff Bunza. He's one of the guys that I follow on Model Railroad Hobbyist. There's another one. I'll think his name in just a second that I'm super fond of his YouTube channel for. A lot of these guys are doing that work and sharing it. So learning how to fritzing your own diagrams or to copy and paste a little bit of code so you can see other people's work is entirely valuable for when you want to do something ever so slightly custom. But there's so much of this stuff already available out there that you could reuse.
Yeah, there's tons. And like I said, and sometimes you have to watch too, because you can get a piece of code, copy and paste it. You might have some problems. You might want to modify it. So it doesn't hurt to kind of learn a little bit of the code side of it. But if you want to start off, like Andy said, copy, paste, run it, and see what it does, and then just keep implementing baby steps, one step at a time, to get to start learning this stuff. And I said, YouTube's a wonderful thing. Model railroaders use that all the time to learn how to make track, to learn how to build bench work, to learn how to weather locomotives, everything.
Changed the game in model railroading. In my opinion, YouTube changed the game for us.
People are using YouTube to fix their cars. It's a great thing. It's a tool. I mean, utilize it. If you're not a person, I mean, I learn more by doing and seeing than I do by reading. I can learn by reading, but that's my mentality. Because I'm Polish, I learn by watching something. So that's how I pretty much learned. And I only started watching YouTube videos at night on the couch when my kids took over my TV. And I was, watching Arduino videos and blah, 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 blah. And then 4 months later, I bought my boards. I bought a Uno. I bought a Mega. I have a Wi-Fi enabled board now. I got them all over here. I got them crawling out every surface. And
look at the community in YouTube Auto Builders. There's more than a dozen of us. Maybe several dozen of us that are actively pursuing a light education in this, or sharing information and working together to get speedometers built. And lighting is the easiest way to bring a layout to life.
This is just the beginning, folks. This is just the beginning. This is not something that's been going on for 10 years. This is just getting ramped up. So I mean, if you start now, you might be better off than wait until later. But okay, let's get off our soapboxes here for a little bit. Let's build this last circuit, and if we have time, we can get back to the soapbox and have a little powwow or whatever. What are you thinking, Andy? Is that okay with you?
Of course.
Okay. So the next one we're gonna do, we're gonna do that. Let me share my screen here. So while we were talking,
I'll follow you down in the rabbit hole.
you tend to do that anyway. So while we were sitting here talking about the pros here of using this stuff, I loaded up a new fritzing diagram. This one we're going to do is we're going to use a servo and a push button. And the purpose of doing this is to simulate using the Arduino and the servo to throw your turnouts. So go from through to divergent. So I'm going to stick to using the Arduino Uno because for the beginners out there, it's the board that a lot of tutorials are based off of. So I don't want to throw, you know, the Nano in at you or anything like that. So we're just going to stick with the Uno, even though we're not going to utilize every pin. But just note that there's boards out there that are a lot smaller and compact. And maybe Andy can maybe pull one of his out to show you on the screen really quick what I'm talking about.
They're cheaper.
Yeah.
And smaller fitted things. If you go to Arduino.cc, there's several dozen board form factors. And if you go search for Arduino compatible, there's hundreds, if not thousands.
Yeah. Banggood's a good source too. Adafruit, Banggood, eBay. The boards I have, I got off eBay. They work perfectly fine. So you'll see like an Uno retails for $20-some usually off of one of the resellers for Arduino, but really you could buy them for $5. I bought the Uno for $5. I bought my Megas, and I'll show you a Mega really quick here. Let me stop screen sharing, just so I'm not throwing names out at you. This is a Mega. So the Mega has 54 input-out ports pins on the board, multiple communication lines on it. It's like it's the Mega. It's the Mega board.
More storage, more power.
The name says it all. These are great boards. I tend to lean toward these. For bigger stuff on my layout. I like to try to minimize the number of boards that I use, but that's a topic for another day.
The DCC++, the de facto way to build that thing is on an Uno, but there's a lot of people building it on Mega with improved
because of the RAM and the CPU on it. So
yeah, but if you build it on an Uno, it will run on a Nano. If you build it on a Nano, it will run on a Mega. It may not work from a Mega down because of the number of pins differences, but it's that family of stuff. So if you learn how to work with wood, you have thousands of boards.
Yep. So, all right, let's go back to what we're supposed to be doing. So what I'm going to do now, like I did before, I'm in my parts library. I'm on Arduino. I'm going to bring my Uno out again. And as long as it didn't confuse anybody before, I'm just going to rotate this just to kind of make it a little easier to work with. So we have our board. So now like I said, what we're doing is we're going to use a push button to activate a servo. So we'll go into our core libraries again, get our push button. So I'm going to bring my push button out, and I'm just going to drop it on my breadboard right here. Actually, let's put it down here. Or give us a full room. So now we need a servo. So a servo is another basic component. It's a core component in Arduino.
You may have to span that gap with that button too. It depends on how you position the button. I generally recommend spanning the center gap because it's easier to figure out. Because two of those pins are contiguous.
All right, so we'll do what Andy said. We'll put it at the center just like that, and then we'll bring our servo out. And the parts, sometimes the parts, it matters what part you use in the fritzing diagram. If it's not a basic component, with a servo it doesn't matter. It's just what brand you use or whatever, or what you use in your diagram. This is just showing you a basic servo. Every servo is pretty much the same as far as connections are concerned. You know, internally some elements change, but I just kind of want to clarify that you don't get hung up with that. You know, you have a Power City 9G servo, and you're looking for that in the fritzing diagram. The other component that we're going to need for this too is we're going to need another resistor, and this is going to be a pull down. So when the button's sitting there floating, not pressed, it's tying it to ground. Did I pass the resistors? Probably. Yeah. So here we go. So I'm going to bring that out, and while we have it clicked, I'm just going to use a 10K, just because that's probably good enough for the button. And I, you know, I'm arbitrarily choosing these as we do this example because, you know, we're just kind of over showing you the power of the program and how to lay out the circuits. It's not really about the electronics aspect of it so much. But if you know, as you do examples through the tutorials, you'll find that people tell you, well, you use a 10K, and you could probably dive deeper to why you use a 10K versus using a 5K or another value.
Like everything else, if you start, you wouldn't probably jump into the hobby unless you would jump on Lloyd as an example again. You probably wouldn't jump into the hobby and start scratch building day one. You'd start building some kits to get some flavor for how they go together. For
right.
order. Same thing's true about Arduino. Go find some sketches, go build a couple things, make a few things work, look at how they work.
Yeah, exactly. So what I'm going to do now is I'm going to bring my resistor over. And let's let's see here. Let's hover over it. Again, we're going to hover over this part. Pin 1. These things are kind of tough because it's hard to tell. I don't think it really... Does it matter what I forget. Does it matter if there's which side's positive, which side's negative?
It doesn't. There's not a positive negative on the push button. It just makes a contact. The problem you run into with most of the push buttons are they have 4 pins and you'll have continuity between them. And I just about always, when I order different ones, I about always have to take a continuity or a multimeter. Just buy you a $3 multimeter. You need this for your layout anyway.
Right. So, all right. So we're going to put this resistor in here. We're going to rotate her. And we'll just say we're going to make this side our negative side. So we're going to bring this up, bring this down. Now see how this doesn't connect? Let me zoom in here a little bit. Kind of for the viewers at home to kind of see what I'm going to do. So here we have our push button, and it's connected over this, what we call this break, or there's the dip break in the board. Okay, and we were putting this resistor on. So this resistor's in this pin right here, this hole. So you see how it doesn't reach to the negative rail? Now watch what I can do. I just extend that out. Bam. Now it's connected. So now I just extended that leg. Because with a resistor, you got to remember, and I have one here, but it's too small to show. Those leads are bendable. They're not rigid. So they're made to flex to kind of go in. So this is kind of representing that. So now we have our pull down. So we're pulled down the ground. So but now we forgot we have to connect our breadboard to ground. So what I'm going to do though is I'm going to bring my 5 volts out and my ground out. So again, we'll go 5 volts to the red rail, which is this one right here. Okay, we're going to change the color of that to red for 5 volts. And we'll just kind of do this a little different than we did before. And we'll bend the wires. Again, neatness is key here because remember we're prototyping, or we're trying to remember what we did. So if we keep it neat the first time, it's going to be a lot easier to come back to this in 6 months to a year or whatever and remember what we did. So now I'm going to connect my ground to the breadboard from the Arduino Uno. So now we're going to bend this wire around. And it doesn't matter which way you bend it. You see I started at the Uno there, and the last time I started at the breadboard. It doesn't matter. So now we're going to make this nice and neat. For kicks and giggles, we'll make this one blue to match the breadboard. So now I have my 5 volts on my ground connected to the breadboard. So now this resistor is automatically tied to ground because, again, these rows at the top of the ground or negative rail are connected electronically along the horizontal of the screen like those yellow dots are showing. So I'm done there with the push button as far as connecting it. I got some crap in there. Sometimes when you click on this stuff, you get crap in here, and it's hard to delete, but we'll just ignore it for now. It's not going to really affect what we're doing. So now that the push button is, now we got to connect the positive side of the push button to a pin on the Uno, because we need to read that in our code. So when the Arduino is running through its constant and infinite loop, it's going to read, see if that pin's reading high or low. So if it's not pressed, it's going to read low. If it's pressed, it's going to read high. The way I have this set up. If I put the resistor on the positive side, that would mean I'm going to pull it up. So that means, no, I'm sorry, pull down on the pin. So when I push it, it's actually going to read low versus reading high. But for this example, we're going to read high when we're pushing the button, which is the way I like to kind of do it if I can, because I always like to think of that high as something's actually happening. So I'm going to connect my push button to pin 2 on the Uno. So we'll just drop this onto here. And we'll just pick a color, any color. Say green. So again, we'll clean this up a little bit, make it nice and neat. So now the push button is connected to the digital pin 2 on the board. Okay, so now half of our diagram is done. So now we got to do our servo. Now what I'm going to do here is the servo has, when you have a servo, for the people who are not familiar with it, you have a PWM line or a pulse line. You have a power rail, which is this red one here. So our yellows are our pulse, our red is our voltage, and our black is our ground. Now I'm going to connect this. I'm going to have the Arduino supply the power to the servo. That's typically not a good idea if you're running 5 servos off the Arduino. But for this example, because we're only running 1, it's not going to really be a big deal. I've done it before physically and never had a problem. But like I said, if you're going to run 10 servos, you're going to want to bring your 5-volt rail off your layout and power that servo separately from the Arduino and just connect the pulse line. So to kind of illustrate what I'm talking about, so this is our ground. So I'm going to bring it over to the blue rail on this side. Okay. So we're going to connect it like this. Again, I can't stress it enough how neatness is the key. Okay. So we'll leave that black, and the reason why I'm going to leave that black is because it matches the wire on the servo. So now we're going to bring our voltage down. So that's red. And I didn't know the program can do that. See, I learn something new every day too. That it's automatically picking the colors based on the servo lines for some reason. So now the servo has power from our positive rail, and it's connected to ground. So now what we need to do is we need to connect the servo to the Arduino so that the Arduino can send the pulse width, which is using PWM signals to tell the servo whether to be at 0 degrees, 90 degrees, 180, or negative 180. So we're going to bring our wire from here, and I'm going to connect it to pin 9. And how I know that's a PWM signal is I'll explain in a minute after I kind of fix my wire here so it's a little cleaner, so when we talk about it you can see. I'm going to explain here in a second. Okay, so now we have our voltage again, our ground, and our pulse signal, which is really the transmit signal from the Uno to the servo. So I have to connect that to PWM. So if you see here, on our digital pins, anything that's a PWM pin has this little squiggly line. So pin 3, pin 6, and pin 9, 10, and 11 all are PWM pins. So I can connect anything that needs pulse width modulation to one of those pins, and I can control that part with those pins.
Like a servo or a dimmable LED if you
Right.
adjust the brightness.
Right.
There's a lot of things that PWM does A lot of us that are fond of the Woodland Scenics Light Hub, which I think is for the buddy is incredibly inexpensive. I mean, Arduino's better because it gives you control, but for a lot of people who just want lights, the Woodland Scenics little hub gives you PWM. It's not just a dimmer. PWM is like dimming an LED the proper way.
Mm-hmm. Yeah, and you could do that with a basic LED too. You could control its brightness with a like those LEDs that we just did in the first example. I can put them on PWM pins, and we could
Dim them, brighten them up, adjust.
Yeah, actually only one of them that I put on a PWM pin, but that pin can also be used as a normal regular pin too on the board. But if we really wanted to take the white one and dim it based on whatever, say we had a sensor on it and we were trying to pick up the room light, the LED can kind of tell you how much light's in the room by using pulse width modulation. So we go back to the servo. So this is like pretty much like the prime example for model railroading right here. Okay, because I have a servo that's gonna take one of Andy's highly detailed turnouts that he makes, and he's gonna run it for him. So it's gonna take it when he hits this push button, it's gonna take his train into a siding, or when he pushes again, it's gonna bring it back to the main line. So this is like a prime example. So when if we have this board and we say we're in a yard, we have an engine service yard, and we have five turnouts, I can add 4 more push buttons and 5 more servos, and run the whole yard from one board. But again, we wouldn't want to really have the Arduino supply the power to all those servos. We would want to kind of break it out, and we could do that. A lot of us talk about DC, using a 5-volt DC power supply through your layout. You run a bus line, connect all your Arduino boards up, and you just put a terminal block off, do another tap into that bus, and then you could connect the servos up to that bus and not have to worry about the Arduino. And they're going to share the same ground because they're sharing the same power source. If you weren't sharing the same power source, you're going to want to tie the grounds together so that you don't get any problems. So like can I make that servo actually move in the program? No. There's another program that I know does. Oh, and you can't do animations
Or simulation might be a better word. You can't simulate the operation.
Right.
There are software that do that.
I think 123 Circuits does that by Autodesk.
Yeah.
They do that, but fritzing is purely just laying out the breadboard diagrams, the schematics, and the PCBs like we overviewed. So
simulation's not for the faint of heart, and since it's so easy to prototype on a breadboard with a real Arduino, I've done many circuit simulations in years past. I went to college for electrical engineering, designing circuits years ago. We used simulators for all kinds of stuff. DOS, so it was that long ago. But we used simulators for that, and that made a lot of sense. We were working with fairly complicated electrical circuits built from scratch. For Arduino, it's pretty hard. I won't say it's impossible, but it's pretty hard to brick one. So, if basic things, don't tie the power to ground. If you're not doing those basic things, you're safe. So you could prototype real world on real electronics with lights that really come on, as opposed to a simulator. So I'm not saying a simulator has no place. At 123 Circuits, there's actually quite a few of them. There's a web-based one that I like real well that you can take your fritzing diagram and put it in the web-based one and let you simulate. It's not generally necessary for most of the circuits we would build. If I was I use the DCC++. If I was actively programming and working against it, I may want to simulate that. There's some complexity there.
Is there any questions or comments, concerns in the chat while we're here? Or?
A couple of guys, Martin and Andrew and Lloyd, chiming in, talking about the clones versus official argument. And there is some challenge to which to buy there. I use an official for my DCC++. I like supporting Arduino. I like supporting that organization anyway. So I don't care to pay a little bit more. I will for certain projects. I build sensors for network racks in my day job because I can pay a lot cheaper and I can buy them. They're hundreds of dollars to buy. And I use our officials. I know what I've got with them. They also tend to work better straight out of the box, especially with Windows. When you first plug them up, the driver issue of making the Arduino's onboard serial connector adapter. It's a FTDI is the technical term, but it produces a serial port through the USB, old school serial like we used to mess with 20 years ago. The officials have better support. They're natively supported in Windows drivers, whereas the clones tend to require you to install an additional driver, or at least they have in times past. If you are going to buy one Arduino and that's it, or you're just getting into it, I would probably encourage most people to buy an official. Buy a certified one, and I can show you the difference in them too. But on the bottom of them, they have well, I can't get that unplugged very easily. They have you could tell they're official. Some of us could show you that somehow.
Yeah, this is an official.
There you are. Thank you. But if you've got 100 of these things, then I've got clones. I'm going to use clones, but I prototype and build against official. I test with official, and most of the time that I'm when I'm on an Arduino show, I'm using my official or my Arduino whatever it is, not a clone. But I'm actually, most of the stuff out of my layout so far, I've got a couple out there right now running signals. They're all clones, and I have fine luck out of them. But
yeah, if you're gonna buy a clone, just read the reviews on it. I mean, that's what I recommend. That's what I do, because that way you know if it works or it doesn't work, especially if it's on Banggood or Amazon or eBay.
Yeah, I've had really good luck out of the ones that I've got from Amazon. I did order some from eBay some time ago that gave me a little bit of trouble. And that's kind of what I decided. I'm just buying official. If it's a company, if it's a project for a client, I buy official. No question.
And you could buy official boards off eBay for $5 from China. So I mean, you don't have to spend the $25-30. These are off eBay and they look exactly like real ones. And I don't know if they are, but they look like it.
I'll buy original woods off from Element 14. Search Element 14. There's another name for what their site is. I can't think of it right this
Newark.
Yeah, Element 14's their electronics. They have a channel. They do YouTube videos. They do forums, all that stuff at Newark, and that part's called Element 14. And I buy a lot of stuff from them. They have the officials, relatively good prices, relatively available. A lot of the kits that we buy, that we started our Arduino show with, that Chris Heili picked out some kits and stuff. I bought one too, so I could be like all the cool kids. Most of those come with generics like Elgoo or some crap like that. Generics, they're fine. It just if you're only going to buy one, or if you're going to use it for a critical thing like your DCC++, I would probably encourage you to buy an official. If you're going to use 100 of them, buy some generics.
Yeah. So is there any other questions in the chat, Andy, or are we good?
I mentioned another one, KiCad, whatever, KiCad. I've heard of that one. I've used a few. I like Eagle. Yeah, KiCad is what Andrew looked at. I've heard of that one, but I don't remember if I've looked at that or not. I've used Eagle CAD. That's a good piece of software too. If you're really doing circuit design, Eagle CAD is preferable. It does simulation.
And if you really dive into PCB stuff, that's the program I tend to go to too.
Absolutely, without a question. But what we're encouraging here is documentation for your own purposes to keep up with it and to build a base, and then modify it 3 or 4 times for each particular deployment on your layout. If you've got different buildings, build a base with some lights, and then make subtle changes as years go on or as you build your projects, or for sharing in our community. Of course, we love that. Most of us have went down this rabbit hole, as a collective group together and sharing this stuff. Fritzing makes that infinitely easier. Didn't turn his quality down probably, but I'm going to paste that.
Can I ask a quick question?
Sure.
Okay, I'm just going to share you. I want to know if there is a way to, you can see the black wires. Like, let's say I don't want to use a breadboard. I just want to show where the wires are connected.
Sure,
Is
directly.
there a way to add a black wire that all the way down to connect all four? Because those four are ground.
Yeah, there is a way to do that.
Yeah, try to add that wire down. So
What I've done, I know how I've done this.
Draw a wire down.
I've drug it off.
Oh, you mean put it here?
No. Draw it. Go undo that. Draw a vertical wire. Draw another wire. There you go.
But that's not a wire. That's nothing.
That's
an highlight.
Take that wire, drag it,
yeah.
Grab it and drag it down some, or grab it and then go up in the middle of it and grab that black wire in the middle, and it'll
do that. Okay.
That's electrically, it's not identical because you won't get a circuit completion light. There is a way to get that too. I will circle back to this offline because I've done that. I know how to do that, but for the purpose of documentation, that scratches the itch.
Okay. Okay. Thank you.
You're welcome. All right, Johnny, I think that's, if there's nothing in the chat and nobody has any comments, I think we can wind this down.
Greg mentioned Autodesk circuits. That they have a whole suite of stuff. 1, 2, 3, they have a whole suite.
All right, I'll let you get that posted up for Andrew there before I shut it down. Oh, Brunette 42. I was saying good night, guys. Usually a substitute is a substandard. You have done a great job, Chris. We will be proud of you.
Thank you very much.
So,
watch his next shows coming up every week.
I don't know if Johnny will have me back, but we'll see.
If you support Chris on these shows, support our sponsors at blah blah blah. No.
Yeah.
Happy to have. We're glad to have.
All right, Andrew. Andy's going to put a link in for you. Not YouTube Model Builders.
Oh, you want Arduino?
General.
Oh yeah.
Or, Andrew, go to the link that Andy's putting up so we can see what's going on with you and the internet and see what we could do to fix all that so you can get into the other rooms with more people. So you go there in a few minutes and Andy will meet you over and talk to you about it. So actually it's just take out the YouTube Model Builders and put the word general in there.
I got it.
Well, did you?
Yeah, I just have to edit all these links because they won't let you paste a link.
Yeah.
Edit it, put dot and quotes and.
Yeah. All right, so hopefully you got that so you can get over. We see what's going on with you, Andrew, so we can get you in there.
I'll be over.
Yeah, I apologize for the interruptions tonight, but my internet I thought was stable again, but evidently it wasn't totally stable, so we had interruptions in the show. But anyone that wants to, we go to appear.in / like Andy put in the chat over here, it's called appear.in / YouTube Model Builders. There's usually somebody there almost every night.
And we have Arduino rooms, and we break off and chat about that or Jabberai.
Yeah, we do. It's a little bit easier now. It's a little bit easier now in this because we do have other rooms. So our main room is YouTube Model Builders, but if that fills up, we can go to another room really easy just by clicking on a room. Now we don't have to open up new Hangouts or anything like that. So we can entertain more people, you know, in these video chats that we have every night. So if y'all want to, feel free to come in. Be glad to have you in here. Be able to help people out where we can. You know, if you got problems, come in and ask. We'll see if we get somebody in here to help you out. All right, great show, Chris. Appreciate you filling in for Chris Heili.
No problem.
Chris should be back next month on his regular shows again. And well, I want to say go to YouTubeModelBuilders.com. There you can check the schedules for Tuesday, Wednesday, and the Saturday live show. The Tuesday, Wednesday shows are 8 o'clock Central, 9 o'clock Eastern Time. The weekly Thursday show and the Saturday live show, once a month live show, is 9 o'clock Central, 10 o'clock Eastern Time. And also while you're there, be sure and click on the eMag tab and sign up for an email notification when the magazine comes out, which is this month. Be sometime around the middle of the month or a few days after. JD and his team are putting the final touches on this month's issue, and everybody usually enjoys those. They've always got some great articles in there. JD and his team do a good job putting that together, and it's a free magazine too, so can't beat that. Well, with that said, we appreciate y'all coming in. Glad to see everybody tonight, and we shall see you this Thursday, huh? That's tomorrow night, on the general Thursday night hangout, the one I call Slightly Controlled Chaos. Yeah, very slightly. Hopefully my internet connection will be a lot better for the stream. All right, everyone, have a good night. We'll see you tomorrow night at 9 o'clock Central, 10 o'clock Eastern Time.